that point here in a second. Okay? So far, so good. Well, just like in two-dimensional lines, we start with the equations, find the equation of a line with point and slope given this and this. Then we bump it up to find the equation of the line through 2 points. Let's do the same here for vector, equations of line 3 dimensions. Find the parametric equation of the line through 1, 3, 5 and 0, negative, 2, 1. Because the same thing still is true in 3 dimensions. 2 points determine a line. Just like in 2 dimensions. You got 2 points. There's only one line that goes through those 2 points. Same is true in 3 dimensions as is 2 dimensions. All right, but to get this parametric equation, remember what we needed? We needed a point and a vector. So we needed a point and a vector. Well, we've got a point. We've got 2, matter of fact. What's missing? We need the vector, okay? So how am I going to get a vector out of 2 points? Yeah. You can, yeah, if we've got these 2 points in space, I don't, this isn't drawn to scale, but we've got these 2 points, and so wherever they are, we can make a vector, directional vector, just by using one as the initial point, one as the terminal point, right? By just subtracting the components, right? And so that's going to be our directional vector for our line here. All right, so what is V in this case going to be? 0 minus 1, negative 2 minus 3, 1 minus 5. And so that'll give us a nice little vector to work with here. Negative 1, negative 5, negative 4. All right, and so the equation of the line then, we've got x is x0 plus TA, or AT. Y is y0 plus TB, or BT, I guess. And then z equals z0 plus TC. That would be our equation, parametric equation. So what does that give us? Well, the x0. Now, we have an option here for x0. We can do one or the other. We could either do this one or that one. I'll make a point about that in just a second. But let's just do x0 is the first one here. So that would be 1 plus t times a. Then this will be our a, right? So it would be actually minus t, right? And then y0, so we're using this point, so that'd be 3 plus minus 5t, because this is b. And then z0 would be 5 minus 4t, since c is negative 4. Okay? So that would give us every x, y, z point on the line. Now, one point about this is is not going to be unique, is it? Because like we mentioned, x0, y0, z0, we had a choice here, for one thing. So we could get a second option here. if we say our x0 is this point, then what's our equations? It'd be x0, 0 minus t. So that'd just be minus t, wouldn't it? Y would be y0, negative 2 minus 5t. And then z equals 1 minus 4t. Looks a little different. And that's because the x0, y0, and z0 are different. But this would give us the same points, same line. And then the other thing to point out is if we went back to v here, what if I did 1 minus 0? Wouldn't that be an option? So instead of going that way, I went. This was the initial point. This was the terminal point. And so yeah, that would just change these around to be positives. But it would still give us, and go through the same thing, but it would still give us all the same. It would be different parametric equations, but it would be the same points ultimately when we found those points. Okay. So this is one option for the parametric equation. This is another. There are others. It's not unique. Okay. Now there is, we did parametric equation, we did the vector equation. There's also a third option that sometimes is helpful here. All right, so we've got x0 plus ta, y0 plus tb is y, z is z0 plus tc. All right, if we solve each one of those for t, what do we get? Here we get t equals x minus x0 divided by a. Here we get t equals y minus y0 sub 0 over b. And then this one gives us z minus z0 over c. Okay, well, that sets up a nice little equation, if you will, because since all those are equal to t, x minus x0 over a must equal y minus y0 over b, which must equal z minus z0 over c. This is the symmetric equation of a line. They call it the symmetric equation of a line, and just another way. Because if you think about it, all three ways have 2 bits of information. They have the x0 and they have the a, and y0 and the b, or I guess 6 bits of information. Okay. All right. So just another way you could represent the same information.